All right, our next presenter, some of you may remember Vang from last year. He's the one who won the device that Louis handed out at the end of his presentation. And today, he's talking to us about something we haven't really heard about at DConf before, the use of D in bioinformatics. So, Vang, please take it away.
Mike? Can you hear me? Yeah, right. Yeah, so it's very good, excellently good to be here. I mean, it can be even better if I'm here next year. So, yeah, thank you for being here. I see so many of you here, still very energetic, so it's good. And today I'm going to share with you our experience about adoption of D for genomics, bioinformatics. And more importantly, I would like to take this opportunity to invite you to join these fantastic areas which can make a great impact, positive impact on medicines and humanity as a whole. Yeah, so because we are in the AI age, which stands for age of the impatience. I would like to show this first, and ideally I would like to jump right away to the stage 6. That is to use the D as the main language for big data and bioinformatics right away. But that doesn't happen right now. So that's why I'm gonna go deep into the details and show you what is the current status and what we are having difficulties with and what you can join and be or have collaboration with us. So I will go through this part. Basically explain a bit about the background of our work and our also kind of very careful consideration of how we come to D after all. And then the status of current adoption and number 6 again. This is our thoughts of how we can develop and growth together between bioinformatics and D, and some take-home messages and the coding challenge. Who here have looked at the coding challenge I post on forums on Tuesday, I think? Not many. So please take a look at the challenge. I will explain more later. And so I'd like to say a bit about my background. And basically, I use many programming languages from starting from interpreted or scripting language to the compiled language. And the latest addition is the D. Most of the time, it's not me to actually start learning the language because I have some hunch or something. It's because I find some really useful tools that is written in that language, and then I start, okay, yeah, check out and maybe learn something and learn about this language and hack the tools for our use case. And with that, I see that D is a perfect, the optimal choice with balance out of many things. And we can share interests and make collaboration and have jobs opportunities. And in turn, the ecosystem will grow with tools and libraries and learning resources. And here is where I'm working now, in the northern part area of Denmark. And I'm working with actually 20 employees out of 6,000 employees in the hospital. And we have offer the molecular diagnostics service, which use the infrastructures of the 10 Linux server or mini clusters. And we have about 300 terabytes of storage, which is software-defined storage. And in total, about 1.2 terabyte RAM. And yeah, you can read the rest. But the teraflop calculations, that I exclude the GPUs. You can see there. And the data volume we generate from, say, last year, we have about 8,000, we process 8,000 samples, including different kind of samples, and generate about 4 terabytes of raw data per month. And after processing, we keep about 1 terabyte. And this is the area that we mostly work with, this NIP, PGS, and genetic disorder detection, cancer, diagnostics, and virus genotyping. This sounds like a biology or medicine conference now. Yeah. Well, I just try to introduce what we do, and here is the one example of the NIPT, and well, the baby inside the mother womb connect with this umbilical cord, and until recently, I didn't know that early, but like 10 years ago, they found out that there is some material from the baby that get released to the bloodstream, into the mother bloodstream. So that is very precious and very important clues. That means we can get information about the baby without having some intrusive or invasive method to have higher risk for the baby. We don't have to use a needle or something to get the fluid or something out from the baby. So we can just take the mother blood and then extract the DNA, and then we sequence the DNA, and that sequence will offer the clues, for example, about whether the baby has the genetic disorder or some mutation that can be risky for the child. So this is very interesting now, and we are offering this service for many high-risk cases in the Onboard University Hospital. And a bit briefly about what bioinformatics is. It is the overlapping areas of three science. It is the biology or life science, and math or statistics, and computer science. The biology guys, like me mostly because I'm a biologist by training, will give questions and have the need to do something, and the math will help us to plan experiment and see how we can collect data, collect samples and do how to do it correctly and statistically correct. And then the computer science part is to implement the analysis program and give answer to the biologists or life scientists, and they will evaluate, and then the cycle may loop again, like that. And we usually receive the data in form of text or image or database, mostly text that I work with, a huge file of text that contain DNA. And we do processing of the data in mostly parallel or distributed manner to reduce the amount of time. And the output usually is the graph or summary text table to have for evaluation. And the data, as you can see, the genomics data, it's come from the DNA strands of the cells. And this is come from the chromosome. Human has 23 pairs of chromosomes. And my data come mostly from this DNA blueprint of the cells. And it's amazing when you think that, like, they estimate when a person, normal person, when all of their DNA extracts it and connects together, they can make like 1,500 times from Earth to the moon, back and forth. That's the length of the physical strands of DNA. That means if we sequence someone, we can get a huge amount of data. And I actually deal with big data before I heard the term big data. So, and again, here's the flood of big data. It is estimated in 2015 that there are about 1 million human genomes has been sequenced. And the total amount, you can see on this axis here, the total amount of data is several hundred petabytes. And it will reach the exabyte threshold in 2020 quite easily. And it exceeds the Moore's law and exceeds the prediction of the Illumina company, which is the biggest sequencing company at the moment, or company that produce sequencing instrument. This is the real curve. And that brings the big headaches and challenge to everyone working in the area. It's a great, how you put it, it can be also a great opportunity for you to learn something or develop something new to help with the situation. Right, and not only in medicines, bioinformatics also help to analyze data in, of course, biology and agriculture. Maybe somebody are opposing the NGO. I think the genetic modification organism, GMO, sorry. Yeah. And astrobiology was there. Somebody tried to use bioinformatics and genomics to kind of figure out what would be the characteristic or the sequence of the extraterrestrial. But now they actually collect the data from the air very high above the Earth's atmosphere. And archaeology, this is something of kind of an unexpected addition to the service of bioinformatics. But actually they use the bioinformatics to figure out the migration path together with archaeology evidence, of course, that the human species, the modern human species, migrate out of Africa about 65,000 years ago. Yeah, that's so very interesting. And bioinformatics is under all of this in terms of data analysis and planning of the analysis. And I hope that D will be the power or the core power of bioinformatics soon. Yeah, so in doing bioinformatics, we manage data storage, or we do data mining, or manage the metadata. When there are too many samples and case from this patient, that patient, and this patient come to test this year, then next year they come, and there's so many things. So that metadata management is also very critical. And there is the big, also big business now. They develop this LIMS. Who knows LIMS is? The Lab Information Management System, which help with manage the data. Right. And also, you don't have to read all of this. I just put here for future viewer that the software tools used in bioinformatics are very diverse, including many different programs. And I really like this one here, the Conda. Who here using Conda? Okay. Just a couple. But I really recommend it if you want to have some very lightweight virtual environment to develop and deploy some things there, testing, and I use it very much and like it. So some other thing written in different language. So you already get a sense that there are many programming languages used in bioinformatics, and D is no stranger or no surprise to be also something bio-D there, right? And if bio even exceeds the realm of programming language, as you may know, yeah, right? Yeah, even have bio-Linux. Yeah. All right. Well, that's just for fun. And so I personally encounter these language, and I really want to maybe focus on some language here and replace some here. You really like when I point here, I think. Well, haven't I encountered these personally? Well, maybe I should not confess that I looked at this some days ago. It actually has quite many stars this on GitHub, but I haven't used it, so I have no comment. All right. I also make careful considerations before I come to D. So this is the kind of very careful analysis that I make. You can read later. I don't need to read all or explain all. I think you guys understand. But I want to emphasize this. It is the Thai. What is Thai? It's tools, industry, and education. This I find is the most three important traits of these four major languages, that it produces tools that you guys use every day or I use every day, and it's permeate to industries and help industry to solve problem and even sometimes create problem and then solve it. And it is educated in schools, and that gives opportunity to generate new generation of programmers or developers to maintain the language. So that is something, if D can do, then D have a much greater chance to have stronger, right? And also, I sum up into this clumps thing. And for me, the first three things is not very strong in D now, but the last three, the 4, 5, 6, is, from what I can see, it's very good. So I hope D will clumps stronger. And the PS part is like PS in the letter, PS I love you or PS I hate you. That's something that we, at least for bioinformatics, platform portability is not a big problem because we mostly run in Linux environments. And for security, it is what I have this statement about security. You know, it is something that if you don't encounter, then you maybe don't pay much attention. This maybe sound like contradict to what Walter was saying, but it is not. You know, if you read it and think carefully. Yeah, all right. And so all of this consideration, and then what a person like me is looking for is something of the beeps. And this kind of peculiar here, why is it a beautiful presentation? If we look through the Nature's publications or many high impact factor journals, then no publication come out with the ugly image, illustration or something. So it's something that if we can do it, so we prefer. That's the point. And yeah, speed is also something really become more and more important now, because it affects money if you use cloud computing, or it affects turnaround, because it like for someone working on routine like us, we have to shorten turnaround time to give answer in time. So it's become more and more critical, actually. Right. I would like to apply that parameters, the beeps, into here and see how they fit. Well, there's a good chance here that D can offer the beautiful things, because the ggplot, the one of very prominent plotting programs or package in our language, has been ported to D, and there's GTK and Qt, so it's very promising, right? And these things, I also see it's much pleasant to the eyes when I look at the code and understand and make it, yeah. And Python, the modernist or readability is also equivalent to Python, but yeah, not to the level of Apple scripts. And built-in unit test is really something I appreciate. I actually, D is something that makes me love writing unit tests, right? And before that, I learned to write unit tests in Java and Python, but no emotion. Right? But D, unit test, is something I really enjoy. Yeah? And I can see that easy to switch between command line, GUI, and web application. It's something like similar to Java. It's also multi-paradigms and strong interface to C and C++. That is also a very strong point. And speed, it's also built-in parallel support. That's also very great. We can do compiled or standalone code for speed and end user, because the end user usually not very computer savvy, and they just want some program to just maybe copy in the folder and run it. So there's no worry about dependencies and so on. So D can offer that, but this is this gives the peace to the mind. And yeah, performance. And I would like say hurrah when I see, okay, I can embed the assembly code, even though I haven't written any assembly, but this is something that if you go really fanatics, you can do some extreme. All right, So here I go to evaluate some common tasks that we do in bioinformatics. This is very, very simple. Actually, it's maybe just for educational purpose. It's not much, yeah, we use sometimes. That if you have a file with this very long and yes, a whole bunch of text, CATG sequence here, and new lines character, then count the occurrence of each type of character, like how many C, how many G, how many A, how many T. That right? It's very simple. And I did this in D and also Python, and try to benchmark that out, right? And this is my benchmark command, run 10,000 times. That's some simple program, and throw away all the output to the console. And I wrote D program and compiled, C program here, and the D program compiled with the LDC and Python program here. And this is to run, I say, with RDMD, without the manual compilation. And the only optimization trick I know is to use this O3 here, right? And you can see the speed, well, here, that LDC, which is D program, and this is the RDMD and DMD compile. It looks reasonably good, or much better than Python version. Even though I don't understand why I use some optimization here, but the speed for DMD is still slower than RDMD. So that's maybe somebody can tell me. All right, and this is just kind of expected. There's a question, I think. Yeah.
So one clue here is that you're like running your command from scratch multiple times, like 10,000.
Yeah.
Well, D runtime takes a bit to initialize compared to C runtime, so there's like 1 point here. And well, you actually need to look more closer to see what's what, but that's one.
Right. I actually post this code on the GitHub repo I'll show later, right? Yeah, and this is pretty good. It's just to confirm what people are already saying, so it's not something super cool. Yeah. And the next task is to write a parser that passed the FASTQ file format. A FASTQ file format may contain hundreds or millions records of these 4 lines record. The first line is headers, the second is sequence, and the third is the optional name, and then the fourth is the quality of the base. So an example here is that if at this position the DNA base is C and the quality is at the @ sign, and that means the quality by this offset, it is 31. And this is the neat way to present the quality, the same column with the data. If you write with number, then it would not stay on the same column. So that's the reason. And well, I come back. That I have been struggling to kind of express this structure in D, and how do I model this and then pass the files, and even one of the requirement here is to have like a kind of range access to the file and also slice access to the file, like both Like if I want the record from 1 to 5, for example, I will be able to extract the records. Or if I want the slice of, say, position 10 to 20 of the one entry, then I also can extract that, or extract all of the read within that range. Yeah, so something like that. So I find it difficult to actually do that in D. Yeah, so I understand the basic D, and I read your book, Ali. What is have little to do with bioinformatics, right? And here's another real work. This is now the real work, not another. I do indexing of the 71 gigabyte of data of 5 BAM files, each about 15 gigabyte of data. And again, here is just to show how I create the Conda virtual environment, activate it to do the benchmark. It's isolated without affecting the other program in the system, and run. This is the syntax for running the two programs, these SAMtools and SAMBambas. And one Java program here called Picard. You can see that well, forget about Picard because it has this runtime. So here, even though I specified 10 threads for SAMtools, it still doesn't use that much and have longer total runtime than SAMBamba. And SAMBamba can use 10 threads fully. So this is another confirmation. And actually, I use SAMBamba because I was not satisfied with SAMtools some years ago when it did not actually have this option to run multi-thread. It's just single thread. It's so slow. So I look up and then found SAMBamba. And actually, this is my entry to D language. When I look at SAMBamba, not look at, but download and run it, and it performed very well. And I say, I like this program. What language is it used to program this language, these tools? So I go to GitHub, and okay, it's D, right? And when I look at the D, at the source code, it's so beautiful, and it's like the love at first sight to me, right? Right? Yeah, this is something that I want to learn and use more. That's the aha moment, right? And so we go back to the roadmap again. I want to do like I do a lot of scripting to call some programs and merge the output or pipe the output from one to the other. So I want to write it, and Bash has been doing fine. But the problem is that Bash doesn't have that richness of the D language to extend, because you never know when you start to do one small script and then the next day a bit bigger script, and then okay, next month the work become more complicated. So the expandability of the program rarely help over time, right? So. And I like it's very. I think it's very promising here, even though I haven't used that much this library, the D library. It helps quite a lot for writing a Bash-like program and then extend it later. And also building pipeline. Currently, I'm using mostly Python, Bash, or even some very complicated pipeline. I use Scala. But I also want to do that. But currently, this is not very much practical for me now. And then actually, that I gain the most out of the number 3 here is to use SAMBamba. Yeah, and the next step I want to do is to port and develop new tools in D. And this is I'm going to talk, and maybe hopefully somebody will join me on the hackathon tomorrow, and then we do it together and develop the GUI and command line applications for end user, and finally be really handle the language and can serve for all the tasks that we do in the office, the lab. And I would like to present some difficulties I saw or experienced. When it's not really a double mission for me, but for somebody who are new to bioinformatics, then they learn D for bioinformatics, then it is a double mission, because then they have to learn bioinformatics, and then there's not much thing about bioinformatics for D right now. So, yeah. And to learn and use D concept, like I mentioned before, is how to express from ideas and from algorithm of the bioinformatic algorithm, then you can turn into D code. That's still very challenging to me. And maybe it's much easier for you guys when you know what you are aiming for, then just, okay, write it down. Like Steve, he can do a lot of things, right? That's example again. And yeah, that's what I mentioned. And these things still very something foreign to my mind now. When talking about ZC and no ZC, I picture a real garbage collector in mind. Yeah, and few world examples is something that I've seen a few people try to use D for bioinformatics, but then they somehow do not continue or produce that much on GitHub, at least as far as I can see. So I want to change that situation, make more real-world example. Like something like this, small, and I'm really happy that Steve and Peter is helping to write the parser. And like libraries, of course, it is another way to say real-world example, but here I'm implying like more the end tools that end user can use. This is for development. And of course, small community. And I hope it will be bigger very soon. Anyway, I still feel very motivated to learn D. I think this is something I wrote, but I think the thing I appreciate the most when coming to D community is the friendliness of the community, and how helpful and approachable or accessible everyone is to ask for help, and I really appreciate it. And I would like to thank everyone for that. Yeah, but being the pioneer maybe not really something that I can do right now, but you can do. Join this field and then make the good application and be the star of the field. And I still want to master this language. It shows so much, many good features. I really want to learn it. It should be here. Sorry. Yeah, and I can see that many C and C++ programs we use, which are the heavy lifting programs under the hood, then D still can take over, inherit these programs and develop further and avoid all the trouble of development with these kind of old language. Yeah. And there are better C and Calypso and DPP. And I get really excited when I heard about better C by Walter the other day. So this is really promising, and that's prompted me actually to encourage me to port new programs into D, right? And so here is what you guys can do, and also if you are kind enough, let me join you. To develop new libraries for, or join these guys. It's the BioD community. And Sebastian and I was making this organization to also promote D for bioinformatics. And you can visit the site. But there are many other things to do there, including machine learning. And here I list, also you don't have to read all of this, the 3 most common tools in the C and C++. You can, with all the knowledge and skills you have, you can start going to this biostats and then translate into D. And that's what I'm gonna do on the hackathon tomorrow. Yeah, and have more showcase of the small programs. And this is my #1 recommended site for you guys and everyone who have a good, strong computer science background, but do not know much about bioinformatics. Then come here and solve these problems with D language, and then please post it to this repo here. Then everyone can find and learn more, right? And it's also an opportunity for you to do master or PhD project or write a project, and we apply and have funding for the work. So to read more about bioinformatics, I recommend some books here. It explains about algorithms, some specific algorithms for bioinformatics. And support other language. It's also something that the community can do, like R and that has RCPP and Java. Python, whenever there is problem with speed, they rely on Python to solve that performance requirement. So D can also compete in this area. So for R, for example, make R and D, right? To have some take-home message here is that the status of our adoption is still very early, but very promising. I'm very confident to go further with D and bioinformatics. All right, and there are some difficulties, like I explained about converting from ideas to the code, but still worth to try. And well, if we have like 10, 20 guys working in bioinformatics, that will be very productive very soon, right? And this is specific for most of you guys. I haven't asked who work with bioinformatics, but I guess 99.9% here are non-bioinformatics, right? So it is very interesting areas and a lot of ground for you to build your careers. So join me, and maybe we can make really interesting things, right? And for some of the fellows, bioinformaticians, the future viewers of this, I really think that D is a good language for bioinformatics. I really like the unit test. Again, I can't help repeating it, right? And it's a really good alternative for C++, and you don't lose the program that is written in C++, right? And please join me on this, this organization, GitHub organization, and see you at the hackathon tomorrow. And I have something here at the last slide. Right? Do you agree with this statement? Right? Right. Thank you.
Okay, we have time for questions, and we have one right here. Good.
Not a question, but a statement. There already is a project to call D from R. It's called Embed R. It's on Bitbucket.
It is already exists? Thank you. I didn't know.
Any questions? Nothing. All right. Vang, thank you very much.
Yeah, thank you.
Okay, once again, we've got some extra time, so come on back at 11:25 and we'll move on to the next talk. Thank you.